Okay, guys, we're going to start. Since we're going to be 8.4 is, guys, please leave that alone. Since we're going to be doing simplifying fractions, rational expression and fractions. So I wanted to review with you guys how to simplify fractions, regular fractions, because it's exactly the same process that we're following. It's 8.4. So, like, if I want to reduce this fraction right here, 14 divided by 36. So, what you have to do here is write numerator and denominator as a product of prime numbers. That's the easiest way to do it. So, 2 times 7, right? And these two are prime numbers, they give you 14. Now, 36, well, the higher the number is, the more difficult it's going to be for you to find it right away. But I don't know if you learned the factorization, the prime factorization with the 3. You have 36, you get two numbers, the multiply give you the number, which in this case will be 4 times 9, right? And then this is no prime, and this is no prime. So we keep going. Factors of 4, 2 times 2, both of them are prime, so you just circle them. And 3 times 3, prime, prime. So the factors are going to be 2 times 2 times 3 times 3. And then we cancel out common factors, right? We cancel out the 2 and 2, and that's basically it. So this is going to be 7 on top over 9 times 2, 18. So that's the fraction simplified. These two fractions are equivalent to the lowest numbers. That's what it is. That's exactly what we're doing in this kind of problems. We're going to be factoring the expressions. Like in this case, you guys have to factor this and this. And that's why in the paper that I passed, you guys have right in front, you have the list of all the factoring strategies that we have, all this. These are the factoring strategies. So you have to be checking numerator and denominator, which one you have to use to factor, and then look for common factors. So for example, here you have two terms, and then you're gonna say which ones of this can I use in this. This problem you already have it in your notes, the same problem. So if you notice it, this is not trinomial, so nothing to do with the second and the third little rectangle, because those are not trinomial. And there's no difference of squares or cubes. You don't have any difference here with a cube or a square x. So the only one you have is the greatest common factor. One number divides 4 and 6 at the same time, 2. Yeah. So you put 2 in front times x plus 3 over, this one is not factorable, so just leave it alone. 2x plus 3. Oh, sorry, it's 2x plus 3, right? And 2x plus 3. These are two are in common, you cancel it out. The answer is going to be 2. However, in this kind of problem where you're canceling something from the denominator and that has a variable, you have to tell me where that is 0 and exclude it. For example, here 2x plus 3 is going to go away. I find the answer, setting it to 0, and isolate in x. So this is going to be 0 when x is negative 3 halves. So I need to exclude it. X cannot be negative 3 halves.
It wouldn't be considered a whole number.
That's what I'm saying. In case if you graph this one like this, that one has a hole at x equals negative 3 halves. But if you don't say anything and you just tell me this is 2, the answer is 2, it's gonna give you the same answer, but with this one doesn't have the hole. But you have to put it there because it was there. That's what I'm saying. You have to be careful with the ones that you
So Mr. You only set it to 0 as long as the things you canceled out have a variable in it?
Exactly. Because if you cancel it 2 or 3 or 4, then you don't have to do that. Okay? So that's what it is for the first problem.